Hello, if you're watching this from home, we've turned in our worksheet, and now we're prepping for notes. Those kids have to be on there for like another hour and a half. It's freaking hot. It's maybe not really the temperature, the sun is intense. And you're on football field, there's no shade. There's no shade up in there. Make sure I don't have to bring easy up. Working with four easy ups.
You get like a drone that constantly flies over you and hangs you off.
And mists me.
What time do we get out here today?
We done talked about it. Okay. We only have a couple slides left, but it's going to take us a few minutes, okay? Because there's a lot of molarity on the SOL test. For some reason, my kids don't do super well on the molarity. I'm not real sure, but we'll cross that bridge next Thursday morning. Okay. All right. Less than a week and chemistry's over. Victory! Touchdown. Okay. Yeah, maybe. This is true.
Unless of course we fail horribly.
Might be victory for some. Although I'm planning on everybody passing because
I'll come just short.
my career record is on the line. But no pressure on y'all.
We're her last group that's taking us well.
Yes.
What if we ball?
Unless I go back in the classroom sometime, which I might. I have a feeling I'm going to miss it bad. I think it's going to be a thing.
I think
Like every day I'll be
you're
like,
going to miss teaching a lot.
yeah, I know I will. I know I
We'll
will.
be yelling at kids.
Because I love it.
Scaring them to death.
That part, we'll just continue. We just, no problem. Okay, here we go. Now, all right, so we're still talking about solutions. Listen to my words. Yesterday, we were here, yes? And what were our two examples of changing the boiling and melting point of water? Which example did I give you for changing the melting / freezing temperature?
Salty snow.
Salty snow, okay? And that is specifically the melting and the freezing. Did we go over the difference between melting and freezing yesterday?
I don't think so.
I don't think we did. Let's talk about it. Landon, put your phone up or I'll take it. Now, I am water in a cup. Yes? I'm the liquid. The cup goes in the freezer. When the water in the cup reaches 0 degrees Celsius, it will what? It will freeze, which means that it turns into a solid. We did call it water, now we call it ice. It's a solid, yes? I am an ice cube. So I am what state of matter? I'm a cube. I'm a solid. And then when I am put somewhere, like in an empty cup, for example, in a room, when the temperature of my molecules reach 0 degrees Celsius, I'm going to what? Melt, which means I turn into a liquid. What is the freezing temperature of water? What's the melting temperature of water? Are they the same? Freezing temperature and melting temperature, are they the same? Yes. So what's the difference between freezing temperature and melting temperature?
Where you're coming from?
Thank you. Where you're coming from. If I'm coming from liquid and going to solid, I'm freezing. I wish to God I was freezing right now. If I'm coming from solid going to liquid, I'm melting. Yes? It's the same temperature. That's pretty easy to sort of reconcile in your mind. Let's do the other one. If I am a liquid and I turn into a gas, if I'm water, at what temperature does that happen? 100 degrees Celsius, and that is the what? What do we call that? Boiling point or boiling temperature, yes? Water turns into water vapor, aka steam, yes? Steam, water vapor, turning into a liquid, does so at what temperature? 100 degrees Celsius. And what do we call that? Condensation. Yes? Freezing, melting, boiling, easy. No worries. Got to remember condensation. If freezing is the opposite of melting, then condensing is the opposite of boiling. Do you follow? Okay? What way did we talk about yesterday that we in our homes affect the boiling temperature of water? It's pasta water. Yes, salting the pasta water. Okay? So just remember those. Just remember those. Okay? Now, moving on, talking about solutions. This is super important. Okay? And again, we're going to spend a little time talking about this. Okay? Molarity is moles of solute per liters of solution. Moles of solute per liters of solution. And the brackets refer to molar concentration. Now, we need to add a little something to our notes here. So go ahead and put your pencil in your hand. Let me get to my copy so I see what you see. Yep, we need to add it now. Okay? So I'm going to write on the board. You guys put it wherever. You put it in your margin. You put it, I don't care. Put it wherever you want. Okay? I'm going to write over this, but then I'll erase it and we'll put the next bullets up in just a minute. Okay? We talked the other day about pH. And remember that we said pH was equal to the negative log of the hydrogen ion concentration. That is like our equation for pH, okay? Sometimes, and when you guys did your book work on pH, when you guys had like 4 or 5 problems in the book and you had to go and calculate pH, you guys saw things like this. It would say, you guys should write this down.
Oh, sorry.
This capital M, okay? All year long, we have used an M as an abbreviation, but it was always a baby M. And it was always meters, or it was milli something. Yes? Okay? So we had the baby M. This is an uppercase M, clearly, full-size uppercase M. This is molarity. Molarity is defined as moles of solute per liters of solution. Molarity with the capital M is also the same thing as brackets is the same thing as, and I told you guys this about the brackets, concentration. Now, focus on my words and listen to what I'm saying. I'm going to give you a sweet tea example because it's friendly. In my house, 2 people make sweet tea. I make the sweet tea. The husband makes the sweet tea. When I make the sweet tea, and we make it by the gallon, We use the same amount of water, same number of tea bags. This is not an issue. So the strength of tea is the same. However, Miss Russell puts 1 3/4 cups sugar. It might be a little bit more, but okay, 1 3/4 cup sugar into a gallon. Okay, into a gallon, which is really not bad because good sweet tea is about a cup of sugar per 2 quarts, which is half gallon. Okay, but anyways, so I put just a tiny bit over 1 3/4 cups of sugar into a gallon of sweet tea. That's real nice. It's sweet. When the husband makes the sweet tea, he puts just a little bit over 1.5 cups of sugar. He's a lightweight. I didn't say that out loud or on camera. But anyways, okay? So he puts about 1.5 cups of sugar into the sweet tea. And of course, the kids always make note of that. Oh, this is dad tea. Oh, this is mom tea. Okay? Now, which tea? Mom or dad tea? Which tea has sugar more concentrated? Mom or dad? That's your choice. Which tea has sugar more concentrated? Talk to me. Mom or dad? Mom. You're like, I need to hear you people. Okay? Because more, when you make sweet tea, one of the solutes in sweet tea is sugar. Assuming it's sweet tea, and who doesn't drink sweet tea, but okay. Okay? So the more solutes you have per a particular amount of liquid, the more concentrated you're going to be. We don't really measure molarity of sweet tea, but we actually could. We could calculate how many moles of sugar are in a cup and 3/4 and put that into however many liters that is, and how many moles of sugar are in a cup and a half, and put that, and the molarities would be different. The concentration of sugar would be different. The more solute there is per liter of solution, the higher the concentration, the higher the molarity. Okay? Now, pH. pH is all about hydrogen ion concentration. The more hydrogen ions you have, the more concentrated they are, the more that's going to affect your pH. Okay? It's not sugar and sweet tea, but it's hydrogen ions in solution. That's what pH is. That's what you're measuring. It's concentration of hydrogen ions. What did I tell you pH was? pH. What did I tell you it was? Well, what's the H? The capital H. Okay. You're scaring me.
Is it per?
Am I here? Are we together?
Yes.
Are any of us actually hear that?
I don't even, what?
Maybe it's all simulation. Maybe
I don't know. Virtual world. Where is
none of you are real.
where is Kegley?
There's no consequence.
They're great.
Oh, that's right. So, I know where the rush is. Are we just missing Rush and Kegley? Just Rush and Kegley. Rush and Kegley. Rush and Kegley. Sorry. Somebody else laugh. Thank you, Megan Kelly. She's lost it. Heat stroke. Y'all are seeing heat stroke right now. Grab your calculator. Oh, God. Less than a week, babies. We got this. Saul's like, I don't know, you better check yourself. Okay, well, listen. Yes?
Mr. Roberts told the time.
Hey, come on. Let me, y'all sit. This is Mr. Roberts' group. Y'all sit right here in these 2 last stations. People, figure out pH. That thing that I put up there on the screen, figure that out. Use the concentrations up there. While I get in this broom cart. Push phone over, I'll take it. Thank you.
I don't know, like, something on my shoulder there.
You guys know what to do with that?
I got it.
What do we got, people? What's our pH? 2.87. What do you do? What did you do? Negative log of that thing right there. Okay? Listen. If you have to, and you may, if you have to calculate pH and you're given a molarity, that's how you do it. You just take your equation that you know, negative log, pH equals negative log of the thing that they give you, basically. Yes? Okay? Now, let's talk about what's the rest on the screen, because that's not really molarity. That's how pH and molarity are related. Okay? Let's move on to what is happening next. All right. So here's the equation for molarity. Do you appreciate that the equation for molarity is also sort of the definition? Yes? Because molarity is moles of solute per liters of solution. And the equation is molarity equals moles of solute over liters of solution. Yes?
Yep.
Why do you cover your ear every time I stand over here? Am I too loud for you?
No.
Last 2 days, you've been like,
Yesterday it was pretty loud.
it's like,
It's a little kid like rubbing his ear. It's his comfort thing right there.
is that what it is?
Yeah.
It's his security blanket.
Yeah.
Because he's in chemistry, because he needs a...
It's like the king of Robin Hood.
Oh, God.
I
Okay.
told you he's so cocky.
I'm telling you, I'm just broken, y'all. This is the heat. This is the heat legit. Okay. All right. Molarity. Moles of solute per liters of solution. Now listen. When you write it, and let me make this distinction, because this, you guys did this sort of beginning of the semester, and I'm not fussing at you. It's just something that I noticed. Maybe 4 months ago I should have mentioned it, but it's come to my mind. Okay. So remember when we did calories? Remember when we did calories and so we would say, okay, a calorie is equal to, for water, it's grams per degree Celsius. And so you would say, okay, if I had 27 grams of water and I started at 0 degrees C and I went to 10 degrees C, so it was times 10 degrees Celsius change, and you said, okay, 270 grams degrees Celsius is what you guys would write. Which really doesn't make sense. This is a calorie. That's what a calorie is. Do you follow? So why I point this out to you is, if you take moles of solute and you divide it by liters of solution, you're not going to write moles per liter. Do you get it? Instead, you're going to have that number, let's say it's 72, big M. That's the unit. Big M is moles per liter. Okay? Do you follow what I'm saying? This, maybe I should have told you 4 months ago. I don't know.
There's just written calories there.
Yeah.
Well,
Whatever.
it'll
Okay.
work out.
It'll bust. Next Thursday morning. It's all over. Okay, here we go. Yes. I don't know.
Oh, we're doing that week. It's not week, no, last week.
I know, we didn't count last week. I don't know. Blah. Alright. Let's do this one. Okay? A solution has a volume of 3.5 liters and contains 4.5 moles of hydrogen chloride. What is the molarity of the acid? Okay? What is the molarity of the acid? What is the math? How do we set this up? What do we do? 4.5 divided by 3.5. Easy peasy. Oh, I get 1.3. Really, actually, the answer should be written 1.3 molar, like that. Now, let me give you a little perspective. I'm not going to go and get this out of the cabinet because it always then stinks for an hour and it gives me a headache. We have, in the dedicated acid cabinet in the prep room, various and sundry laboratory grade acids. Okay? One of which is hydrochloric acid. Now, what is laboratory grade? Laboratory grade is the strongest, most highly concentrated that we can manufacture and then
Melt your face off.
sort of somewhat absolutely melt your face, for sure, okay? But it's the best that we can do, that we can actually then transport and that we can actually then keep in a setting like a school, okay? That laboratory grade hydrochloric acid, which has a pH of 0, at that strength, it will for sure, if it gets on the lab surface and it's left to sit there for any length of time, it can actually pit the stone that is the lab surface in here. Your skin is peace out. Yes, okay?
Sure, we can't mess with that.
Right, yeah.
Can you mess with it and show us though?
No.
Oh man.
It's not very, it looks like water.
Oh.
I mean, it's not very spectacular at all. It's not. But it has a molarity of 12. That is its molarity. 12 moles of hydrogen chloride of HCl per liter of water when you make it. And that's how you make it. You take hydrogen chloride, which is a powder, it's granulated, white. You mix it with water, and that's how you make hydrochloric acid. Okay? When we do laboratories in the science labs, and we need acid, we dilute it. Now, it's been a while since we talked about this, but it's on the SOL test. If we want to dilute an acid, which means we want to make a 12 molar acid, which should not ever be played with, and make it into something that you can actually keep in a regular glass beaker with no lid, we have to mix, we have to put together the acid, we have to put it together with the water. How do we do that?
Acid to water.
Acid to water. Some of you guys still miss this, and it's a very fine distinction. You're like, freaking put them together. Water, acid, water, whatever. They're going together. No? No. The water has to be in the larger amount. The acid has to go to the water. That's what we mean by acid to water. Okay? ABC order. Please remember that. That is the most commonly asked lab safety question on the SOL test. What is, A&W root beer, what is the best way to dilute acids? That's what they ask you. Now, there are other safety questions that come up. Okay, fine. That's the most commonly asked one specifically. Okay? And people do miss it. So just remember, A to W if you're diluting acids. Okay? Now, what is your very next slide? More molarity?
Quick organic.
Quick organic. I'm not ready for quick organic.
So,
No, y'all, because we gotta do some more molarity. Okay, give me a sec. Wait, let me see what's on my slide. Yeah.
So skip that one.
Oh, we gotta do quick organic, but we gotta do more molarity first.
So I skip it for now.
Yeah, okay.